Hello guys, you are welcome to Structures Pro. In today's class, we are going to design this structure, this concrete building with a template which I have developed. This template calculates all the primary loads we need to apply on that structure. I developed this template. They say templates are the strength of every structural engineer. The number of templates you have in your archive determines how fast you'll be in the delivery of your job. And it also determines what you can do. So I've developed this template. This template is for all concrete building, all the necessary loads that needed to be applied to any concrete building. You get them here. As you can see, you have a permanent action, width of plaster, parapet, beam, column, imposed load, and as to code. You can see all these things have reference codes which I will show you as we go. So it is at a giveaway price. It's not expensive, it's less than $15. So for early birds, if you come now, you get it now that the price has not gone high. I will definitely increase the price, but not now. So I'll urge you, if you need this template, just check the description, you see the link there. It also have a load combination. You can see the load combination, all the load combinations, SLS, equilibrium, geotechnical and structural load combinations as to Eurocode. So this template is wonderful. That's what I'm using in my design and it has been helpful. So most times when I design, I don't go to codes again. I just pick this template and follow what is there, because I took my time to get reference from codes and standards, and it is client approved as well. So all the projects I've done with there are no comments that condemns any of the steps I've taken here. So it is client approved. So we have used some projects, and the projects are ongoing, and some of them have been constructed to finish. So it is a good one. I said I will develop it. Some of you requested for a template like this, which is this now. I've done that. So just quickly click the link there, make your payment, and get access to this Excel sheet. It's going to be editable like this. Okay, let's quickly start. The first thing we do, as usual, is we do self weight. So let me just quickly go to geometry. So this building it has two suspended floors, then a roof beam. So we go to loading, click on load case detail, add, then the select dead load here, and I will name it self weight. Self weight, that's my dead load number one. Add it there. So from this template, you can see for self weight, the self weight is calculated automatically. So you can use 1, or if you like, you can add the continuation of 10%, which is 1 minus 1.1. So it depends on what you want. So I will use minus 1.1, adding that 10% contingency. Then I'll click on add. Okay, I'll come here and say apply to view, assign to view. Yeah, I've applied my self weight. Then the next one is assumed roof load. Assumed roof. Okay, this one. Okay, assumed slab finishes. Let me call it slab finishes. It's supposed to be slab finishes. Slab finishes is one kiloton per meter. Okay, I will bury it inside self weight. Okay, we'll add slab finishes. Add slab finishes is going to be a floor load. Yeah. Okay. Floor load in y direction. I'm going to put -1 here. global Y, yes. Y range is from 0 to 6. I want it to be applied on first floor and second floor. So from 0 to 6. Yes. For X direction, we have from 0 to 12. From Z direction, okay, from 0 to 20, sorry. Z direction from 0 to 12. Yeah. Then I will click on add, close. So you see, that's how to apply floor load. Is for the finishes. Yes. Then the next one is weight of plaster on parapet, beams, weight of plaster on parapet, beams and columns. So we are going to calculate weight of plaster. So assuming the plaster thickness is 20 mm, so you have to determine your plaster thickness. Which thickness are you proposing? Are you proposing 25 mm or 20 mm? So if that is the case, you have density of plaster 23 kilonewton per meter cube as per this code, table A1. So let me quickly show you the code. This is Annex A. The code is BSEN 1991. So table A1, construction materials, concrete and mortar. So when you come to mortar, cement mortar, you see the unit weight 19 to 23. So I used 23 kilonewton per meter cube. That's where this thing came from, this value here. So like I told you, I took my time to check the code of practice. So this template is to standard and is client approved. So just use it without any fear. It is what I've been using, and reputable companies are also using them. So just grab it now that the price has not gone high. So we are going to, okay, that's the calculation. So when you put the thickness here, if I use 30 mm here, just watch what is going to happen. See, it has calculated already. So we have inputted the formula inside. All the arithmetic operations have been done. The template is just put the figures you're supposed to put, like this one is typed handwritten. Just put in your thickness and it calculates the rest. So I'll go back to 20 because I want to use 20. Calculates it. That's that. So for parapet, you have to put your parapet height, your parapet thickness. So if your parapet height is 750, like for me now, I'll use 600. Yeah, it calculates thickness is 100, calculates it. So this is the weight I will apply for my parapet, which is 0.598 kilonewton per meter. So it's very simple. So for the beam, the same thing. What is the beam? The beam depth 450, the beam width 225. When you change it to 750, you see what happens. Everything will change automatically. So that's why it's called template. It makes your job faster. You don't need to start writing again. Writing the program. It has been programmed. The Excel sheet is programmed, so just put in your variables and every other thing is going to be calculated. So me, I'm going to go offline to apply all these loads just to show you how the template works. So if you look at the imposed load on floors, live load on floors, it is to standard that we're going to check the section 6.3.1.2 of this same code. So we are going to go up, scroll up to see. See the same code BSEN 1991. The characteristic values of imposed load, residential, social, commercial, and administration areas, categories. So when you look at this table below, see specific use, category, and example. So category A is areas for domestic and residential activities. The example is rooms in residential buildings and houses, bedrooms and wards in hospitals, bedrooms in hotels and hostels, kitchens and toilets. So this category A is what explains what we are designing. We are actually designing a tenant house. That's a life project. Yeah, a life project I'm doing for somebody. So it is a tenant house. So is for residential use, domestic use. So it's not for class B. Class B is for office area. So for class B, it has a separate load. So when you go down again, you now see category A for floors. We have 1.5 to 2.0 kilonewton per meter square. So if you look at my Excel sheet, my template, you see for a typical floor, that's 1.5. So I chose 1.5 for that. 1.5, yeah, I chose 1.5. You can also take 2, it's still acceptable as far as it is recommended by this code. So this is just to show you that I didn't just cook up this, I worked with code as standard. So just grab it now and enjoy it. So I will be going offline to apply all these loads so that I don't make this video very long. I wouldn't like it to be too long. I'm going to apply all these loads here. All this load I've calculated, I'm going to apply it on the structure. Then I'll come back, we do the load combination. Thank you. Yes, I'm done applying all the loads as stated in this template. If you look at what I've done, the self weights, you have self weights here of the structure and finishes. Yeah. The second one is a parapet load on the roof beam. It's the external wall that will carry parapet load. The other one is a beam plaster load on the first floor and second floor beams. It will be plastered. Then we have column plaster load. See how it is. Then we now have life load. We have life load on the slabs. Yeah. So we quickly go to load combination. Go back to our template, the wonderful template. So this sheet is for the dead load and life load calculation, while the second one is load combination. So when you get this template, don't be confused. Once you click here, it takes you to the load combination page, while this one, the first one, is the dead load. So you don't even need to have good knowledge of Excel before you can use this. All the work has been done for you. So I've made the work very easy for you. Your own is just to use it, and that's why I'm showing you how to use it. That's the essence of this video. So now this one is load combination. So we are going to do the combination as stated here. This one is serviceability limit state combination metrics for allowable stress. The combination characteristics, we have SLS. Yeah, you normally number it like 100, 101, 102, 103, that way, in that order. So you have dead load 1, 2, 3, 4, and life load. Yes. So okay, I'm also going to apply my wind load. Okay, we can do that. I've already done that in other videos, my previous videos. If you have missed it, you can go and check my channel and watch those videos. Okay, we do wind definition, and from here we choose the code. Click on add, go back again, click on add, exposure 0.8, and that's, then I will apply to view. Okay, go back again and generate. Okay, building classification, category 2. I'll use 35 meter per second. Velocity, wind speed, exposure category, exposure B, C, use C. Structure type, building structure, yes. Height, above sea level. What's the height of building? You have 369, put 9 meters. 9 meters here. Meters, yeah. Yes, that's all. Consider wind speed up over here, so okay. Click apply. Okay. Then add. That's good. Close. Then I'll go to come back to load case detail. We'll add the wind load, wind in positive X. Copy it. So add wind negative X, add wind positive Z, wind in negative Z. Then can go ahead to define our wind. Come here, choose wind. This is positive X. I will use 1 here. The structure is not open, so I will not check this box. So the wind is going to start from 0 to 9 meters for X. For Y, sorry, for X from 0 to 20, and Z from 0 to 12 meters. I'll click on add. Then for negative X, I'll put minus here. The same boundary condition. For positive Z, remove the minus. The same boundary condition. For negative Z, I'll put minus. The same boundary condition and close. So let me see how effective that is. Okay, that's a mistake. I added all the wind forces under one wind case, so I need to delete this. So it's making all the wind applied in different directions to act at the same time, which is wrong. It's even good I made this mistake so that we learn from there. So we are supposed to separate them. This one is supposed to be under this alone. Then we create another one that will be under this alone. That's the sense we are even created it separately. So if you do all that under one load case, it will make all the wind acting in different directions to act at the same time, which is not obtainable in structural design. There is no way wind will attack a structure in different directions at the same time. So we go back to do for minus X direction, wind load, put minus here, -1 for this 9. for x20 for z12. Click on add. That's that. Then we come to z, positive z, wind load, positive z. We leave it at 1, 9, x20, z12. Add it. That's wonderful. Then the last but not the least, minus z, add, and wind load for minus z, put minus here. This one is 9, 20, 12. So add. That's wonderful. Okay, there is something wrong here. It's not supposed to act on this face, it's supposed to act on this other face. So I will edit for that's for z. It's supposed to be, let me use 12 here. Yeah, modify. Exactly. It's good at making these mistakes, so when you encounter such thing, you know what to do. That's good. So this is I'm done with my loading. The next thing I will do is load combination. But before I do load combination, what I normally do with my structure is I run analysis to see if I will have any error message. So I will quickly do that right away. So I'll click on analysis, define analysis, comma, print all, add. That's good. Then I'll click on run analysis and wait for it to come up. If you are just enjoying this video and you are learning, you are enjoying it and you have not subscribed, I will beg you to please do that right away. Subscribe to my channel, stay tuned and wait for more things that are coming up. I have a lot of things to give to you. I have a lot of templates I will roll out for you for you to easily get your work done. A lot of things and things to teach you for free. I've been giving you knowledge here, software, and I also have other software I'm about to start teaching here on my channel. This channel has come to stay and I will keep posting things there every week, so you have something to learn. Once in 2 days I post, sometimes once in 3 days I post. So if you subscribe to my channel, I will assure you that you will not regret it. You keep learning. Also recommend us to your friends, your colleagues in the office, your students, your sons and daughters who have interest to becoming a structural engineer, civil structural, or a designer, architect. Endeavor to recommend us to them. Thank you as you do that. So as you can see, you have 0 error, 0 warning. That's a good one. So we can continue with our load combination. That's wonderful. So for load combination, I will come and click go back to loading. Load combination, yeah. So the first one is SLS combination 100. SLS combination 100. SLS combination 100. So I'll simply copy that so that I don't. Okay, so I will follow what is here. I will combine dead load 1, dead load 2, 3, 4 with factor 1. That's the first. dead load 1, dead load 2, dead load 3, dead load 4, load factor 1, that's the first load combination. You say okay, then we'll load the second one, 101, that's the second one. So this is how you are going to combine your load. You multiply dead load 1 with 1, dead load 2, 1, dead load 3 with all these factors. Then you now add your life load and multiply it by a factor 1. So this is just the guide according to Eurocode. I checked code, I sat down to do this. It has also been used for projects. I'm still using it in projects. So clients approved all these templates. So it is a standard template, a very global one for that matter, used internationally, worldwide. It is worldwide recognized. So if you find it important and useful, I urge you to grab it now. Grab it now that the price is still not high on the high side. So if you need it, just simply click on the check the description and you see the link there. It is there. You have a smooth payment, very reliable template and a very good one, good template. So I will go offline to actually do all this load combination. If you come to equilibrium combination, you see 0.9, 0.9 for all the dead load for this particular load case. Then you add your wind load 1.5. This one will actually check the if the reducing the dead load by a factor and life load by a factor, then applying a wind load with 1.5 factor, making wind load to be more effective to see how the storage is going to overturn. Yeah, to check how it's going to be how it's going to overturn. So in that, any reaction we get from here is what we use to do our sliding check, overturning check, and the rest of them. So that's just it. That's the idea of that. So with this load combination, you are actually going to grab a lot of things, and it will make you have a lot of combinations, which gives you more chances to check the behavior of your structure, and the structure will actually use the most critical to do the checks and to do the design. So which that's very important. When you do a design and you just have 2 to 3 load combination, people will just know that you are just this beginner, you are just starting. So these are the things that will give you so many options. At the end of the day, you have a lot of combinations like 20, 20, 25 load combination, because you are considering a lot of things. What if the structure behaves this way? What if this one happens? What if that one happens? That is why, that's the reason for all these combinations. They are too much. You get, so you need a template that will remind you of this. So each time you have a concrete design, you just pick it up and your little combination is done. It reminds you it is to standard, it is globally acceptable, and it has been used on projects. It has been approved. So you are lucky you are seeing this. I'll tell you, you are very lucky you are seeing this. It's not seen anyhow, it's not seen in any other place like this. So you just pick and grab as soon as possible before the price goes high. So I will just go offline and do all these load combinations. Like I told you, I don't want this video to be too long. Yeah, I just want it to be a very brief and short one, and you will be able to grab what you need to grab. Thank you. Okay, I'm done with SLS combination, equilibrium combination, and geothermal combination. So I want us to do the ultimate structural load combination together, so that you see how to actually use this load combination template. So we go back to Start Pro. I will paste str for structural combination 400. Okay, so the first one is all the dead load multiplied by 1.35, life load by 1.5, wind load by 0.75. So all the dead load 1.35, 1.35, 1.35, the live load 1.5, and wind load 0.75. Copy this and paste 401, 1.35, 1.5. The second wind load 0.75. See, third one 402. All the dead load 1.35, 1.5. Third wind load 0.75, 4.3. All dead load 1.35, 1.5. The last wind load 0. Okay, that's the first phase of the last load combination. The other one is all dead load 1.35, live load 1.0305, sorry, 404, 404. All dead load 1.35, 1.05, load number 1. Oh, that's what it is exactly. Then we do 405, 405, the same thing, 405. All dead load 1.35, the second wind load 0.5 is 1.5, third one 4.6, 1.35, point 0.5, third wind load 1.5. Last but not the least, all dead load 1.35, the last 1.05, 1.5. Okay, that's the load combination, end of it. So if you check, you see I have a lot of combinations which gives my analysis more things to check out for in my structure. Okay, so see, we have from 10, my load combination starts from 10 to 39. So I have 29 load combinations. So this is different ways that the structure is going to be analyzed. The software is going to check this structure according to these different load combinations, and it will actually return the critical at the end of the day and uses it to design and or to do some checks. That's why it is important to have as much as possible load combinations according to the code of practice that you are using. Like in this one, we used Eurocode. Yes, Eurocode is what we use in this one. I will also do the one for US code, which I have actually done in the past, but I have not given out the template. This is the first template I'm giving out. I want to see how people will appreciate this one before I will roll out more templates. Yes, I'm actually going to, push out some of them, but let me see how this one is going to be appreciated by you guys. And if I'm motivated, I'll put more. I'll roll out more. Yes, okay. We quickly run the analysis and I'll see what the output is going to look like. Yeah, so the analysis is okay, everything is good, zero error, zero warning. So we can go to post processing, and then we remove all the primary loads, yeah, and allow the combinations to be there. So like I've always told you, this is the displacement, how to read your this thing displacement. You can click on displacement summary and to check your maximum displacement. Okay, the maximum vertical displacement is 0.00 the lateral one 2 mm. They are very very small, so it's not anything. So this is the maximum resultant in millimeter. 3.7 millimeter is very okay. It's not too much displacement. That's good. So that's for displacement. You can click on reaction. When you touch the reaction summary, you can see the reactions you have there for equilibrium reaction, see moment, very small moment. Yeah, for vertical force, we have this. This one is for structural combination 155. Yes, 155. We can actually take this one to our foundation design. Yeah, as for that, for beam results. Here you can see the beam bending moment. From here, if you change the load combination, you see the bending moment keep changing. Yeah, that's the output. can increase the scale of the drawing by holding down the control key and scrolling your mouse wheel. See the bending moment is coming out clearer now. Yeah. Yeah. That's for that. We can as well check for share force. One is share force. Yeah, share force, bending moment, share force, bending moment. That's that. We don't have plate here. By the time we take it to RCDC to design our slabs will be designed here. Okay. So for utilization ratio is for steel structures. This one is concrete. So we don't need utilization ratio here. Okay, we are going to end here. Next time we'll take the structure to RCDC to do all the member designs. We are going to do the slab design with RCDC. We do the beams and column designs. Then this foundation of this structure is going to be matte. I'm going to make it a matte foundation. It's just to show you how to design matte foundation with Start Pro Foundation Advanced. So I'm going to do that. So my next class is to take this structure to RCDC. I will design all the members there. Then later I will do the matte foundation of this. So stay tuned. Don't miss out the classes and try to pick this template, this beautiful and wonderful template. It's very useful, and it guides. It's what I use. I will not give you what I don't use. I use it to do my work, and I know how fast it is aiding me. I know how useful it is, and what it has helped me achieve in a short time. Yeah, we will end here today and continue next time. Thank you.